Okay, so this is a domestic hot water heater, geothermal, research line. The customer complaint was that the water was warm, it just never got hot. Couldn't really ever take a hot shower. When I originally approached it, it was running, but it was extremely low on refrigerant to begin with. So I initially went to go take care of that. And I started running into something else. It wouldn't cycle back on. And the temperature in the inlet would jump down to 60. It'd circulate the pump a little bit and get some warm back, but it was jumping to 60 while the hot water was running. So it was actually going backwards through here whenever the water was, so that's supposed to be leaving. It's supposed to be coming out of there and to the water heater right there, and then back to the cold water supply. But instead, when the water was on, it's coming backwards through that fitting and totally bypassing the tank. So that's probably due to a failed check valve. That's probably the little one that I think was a strainer down there was a check valve, and we will have some pictures of it here coming up. Okay, so how this is all piped together is that it will leave going this direction. It'll go through these pipes through here. As you can see, hopefully you got a clip of that. It'll go through here, back down and around, through the pump, out. It'll leave, come back, come up through. I don't know if I'm showing you that. Come back up through here, as you can see, and it comes back in right here. Now that will work as long as we have a check valve. That is a check valve, knowing now. I wasn't sure if it was a strainer before because we had just had a ton of water moving backwards through there and I just felt zero movement. When I remove it, we'll see why. But back to the rest of it. Indicating that it was. So it could just be a strainer. But we could make it work by putting a check valve in here. But at that point, this boiler, it's a heat pump. It only gets the hottest water. Whenever water is running, whenever we're getting an actual demand for hot water, I want to pull it from the coldest water and then pump it back into the tank to mix with all this nice stored hot water. And then from here, we're going to install a recirculation line to come back to the top of that check valve, upflow from it to come in so that it only has one choice. To come back and around through here whenever there is no hot water demand. So it'll make a lot more sense. We have two pipes right here. I'm actually gonna be swapping these for space reasons. I'm gonna take this line that's leaving. I'm gonna put it down here below. Take the one that's coming into the boiler. I'm gonna put a check valve here, and then I'm gonna put it like right here. And I'm sorry, like over here. we'll get to that. But this is gonna probably be my recirc line right here. Oh, I don't know if you can see that. But yeah, I'm probably gonna make this a recirc line to that ball valve, and then bring all the water in through this side. So you can see it's just teed in right there. I wanna bring all the water in, then do all of the check valve and tying in up top where I have more space. So it's gonna look a lot different, but currently, as you can see here, we scribbled it out here, but that's actually the direction here, and we're going to be reversing that for sure. For the recirc line, by the way, this is your whole house recirc line. These are all rusted because there's no dielectric fittings. These really should have dielectric unions on them. Whenever you go from copper to steel, you need to have a dielectric fitting in between to prevent all of that corrosion. And it's just eating everything up. And also you want another check valve. See, that is a check valve. As you can see the arrow, and that's a paddle valve. Once again, they suck. So you'll want a spring check valve on that for sure. But that's just a 1/2 inch. I'm gonna put that on the recirc line coming in. I'm just going to stub out a little 8-inch piece so that whenever you are ready for to get a new pump, perhaps a plumber can do it cheaper, more effectively. But I'll just do a little 8-inch stub out, and I'm gonna cut this and cap it off for now, so that yeah, whenever they want it, or whenever you can get one in, there'll be a spot for it, and it'll just be a quick deal. Okay, new piping. So now the mainline water comes in right here. It goes this way to go into the tank, and then it also feeds this way to the geothermal unit, and then it comes back right here on the other side of this check valve. That way it can't recirc this way. It has to go through this tank, up and around. Now, if you're using water, it'll go it'll go this way, and then some of it will this way. But if you're not using any water, then it'll recirc this way. That's a check valve that keeps the water coming from that way, so only this way, back in to that cold water return where it all started. And so that way, they can ensure that the coldest water is always hitting the geothermal unit, and that the hottest water is always leaving right here. Okay, we are back. Today, what we're gonna do is, since they like that so much, you can see, we are going to mount all of these pipes onto the wall. This is not how I would like to do them, so I made that known. They like my work, so they're okay with me mounting all this to the wall. It's a safety precaution. Yeah, I'm sure someone out there has probably had theirs hanging like this for 50 years, never had a problem. But all it takes is for me to have that problem, for me to be out a lot of money. So we're gonna mount these all on the wall properly. Put the pumps, we're putting in a recirculation. We're putting this nice Grundfos pump that monitors the demand and water temp, so that we eliminate waste and run times and make sure we always have hot water. Put some Unistrut here and here. We're gonna even these out, make those look all pretty. And we're gonna mount one pump here. That's gonna be our recirc pump. And I'll probably mount that loop pump probably right here as well, right next to it. That way we can have everything looking nice. I'm gonna run electrical to it, and then we're gonna insulate it all. Let's get to it. All right, so we are draining this thing. Went ahead and got those installed, so we have a good reference. That way we don't have to have the water off for too long. But we're just gonna rip all those out, and I'm gonna try my best to hang the geothermal pump up there as well, if it's possible, without any socket fusion parts. But we're gonna level that out, secure it all with push clamps, install the pump. Let's get going. Okay, now we've cut all those things. We're gonna start from the back here. I'm gonna probably turn that one. I'm gonna put in a new bail adapter and gonna come up and over in a nice uniform way, follow this wall and go up. Let's get started. Got the check valve out. As you can see, definitely not a check valve anymore. At one point it was, but it stays up in that top position because it doesn't have anything telling it to go down. It just builds crap up there and just stays open. That's why we use spring checks. All right, well, we got this roughed in right here. Just got to do the pump flanges and where those are all gonna land. But for now, we got this ran all the way to the back. We got fresh male adapters. We're running nice and parallel across that. Then once I get those sweat in, you disconnect those and you throw your wrap on, then re-secure them, and you're done with that end. Then you can just be right here. Well, let's get to it. Okay, we're all sweated in. Got a little drippy here and there, but overall pretty good. One more tip. Before you put your insulation on, take a wet rag, wipe all this pipe down, get all that flux off. It's gonna make your pipe last longer, not get all green, not rust these little joints out. So it's good practice. Really, everyone should do it, but that's what happens when you don't. You get that nasty crap, and that's not good. So just do it. All right, well, we still got some insulating to do, but we'll do that at the check and service here in a few days. It's Saturday, 7 p.m. I want to go home. But we've got this bad boy all wired back up. It's cranking out some heat. Got this Grundfos pump put in. It's on auto. We'll get with the customer and we'll set that up for her whenever she's got some free time. But yeah, this thing is complete. We did move this over here just because I wanted to make sure that we would use every bit of energy we could get out of this pump. It's basically going to bypass from here and go all the way down the hot water line and the return. It might give you a little bit, but anything's better than nothing. There's our check valve going in the right, as you can see what direction it's going. And yeah, this bad boy, you can look at some propaganda online about it, but pretty much just a Wi-Fi pump with a learning algorithm. But we've got everything off of those. We got rid of that check valve there. Oh, yeah, push a little bit more. I'll get that next time. But yeah, this is what your boiler should look like when it's installed. Everything out of your face, secured to the wall, running parallel, hung. Look, this right here, this pump, this is actually being secured by this. Whenever I installed it, I didn't even have that one connected. It was just hanging from this flange while I was doing some work down here. So, but yeah, this is securing it, this 1/2-inch cush clamp. But yeah, that's everything. Mine, insulation, which, it's gonna take 30 minutes of cutting it down the side and taping it. We all been there, but yeah. If you want yours to look like this, give me a call, and if yours doesn't look like this, call somebody. Because this is bare minimum right here. There's no sight glasses in this, there's no mixing valves, there's not even as many ball valves I'd really like on it, or drains, or air bleeds, but you don't have to have air bleeds on a hot water system. Just makes life easier. As you can see, I also mounted the geothermal pumps to the wall. They were just sitting in the concrete, soaked. There's a drip. One of the flanges are just completely covered in rust. As for the dielectric fittings, I also put dielectric fittings on the for the pump on the domestic water, but for the geo heat exchanger, it needs dielectric fittings too. As you can see inside this pump, it's eaten up. I didn't replace it, but it's on the list. We'll get to that as soon as we get to the next part of this house. There is a part 2 to this video, not necessarily for the hot water heater, but the hot water heater once again installed incorrectly into the geosystems. Well, you will not believe what I find when I get under that house. I mean, it is just terrible what has been done to the geothermal in this house. But that's for another day. That concludes this video. Thank you so much for watching Nordic Winds Heating and Air's geothermal out of Dallas. Tune in again. We'll get into some more crazy cool stuff, especially with this house. And I've also got a whole nother thing going on at another house just a mile down the road. So like, subscribe, and we'll see you next time.